Okay, we spent with just quite a long time on the matrix multiplication of two matrix. Okay, and then we add this simple analogy between the matrix multiplication of a 2 by 3 matrix multiplied by a 3 by 2 matrix. Now we will love to take examples now. Okay, now let's take examples between a 3 by a 2 by 3 matrix. Okay, so let's take examples now. Let's say 2 by 2 3 matrix of 1 2 1 and minus 1 3 3 2, and then we want to multiply by 3 by 2 matrix like we have done. Okay, so let's call this 4 2. Okay, 1 minus 1, and let's say we're trying to use extremely large numbers for the ease of understanding. And let's say 2. Okay, 2 3. Now it we can apply this formula straight, okay, to get our answer, but however we want to take it bit by bit. So we'll take our minds off the formula completely and we'll take it individually. Okay, so we know that we are having the row multiplied by the column. Okay, now since we started by a 2 by 3 matrix multiplied by a 2 by a 3 this is 2. Okay, we have to know the matrix multiplication order. This is a 2 by 3 matrix, and this is a 3 by 2 matrix. Okay, very very important. So in this case, right, so we'll see that yes, it is possible because the number of columns here and the number of rows are the same. Okay, now all we just have to do is to consider the first row, consider this first column. Okay, consider the first row and you consider the second column, and as the case may be. Okay, so to do this now, let's solve for the first row. Okay, let's solve for the first row. Now to solve for the first row, we will take let me use a different column. So we will take the first numbers together. Okay, that's 1 multiplied by 4. Okay, then we will take these also together. Okay, then we want to make good use of colors. Plus 2 multiplied by 1. Okay, and we still have one more row. Okay, like we've explained earlier, it will be 1 multiplied by 2 plus 1 multiplied by 2. All right, so we are understanding that we are taking this multiplied by this. They are the same number of elements, so we take them in order. Okay, so 1 multiplied by 4, 2 multiplied by 1, 1 multiplied by 2. Okay, now with that done, we have arrived at a solution for the first element of the resulting matrix. Now we want to move into the second. Okay, to the second. So let's try and erase so that we don't get it all mixed up. So for the second matrix now, we want to evaluate what is here. Okay, now to evaluate what is there, let's do it like we did before. We are considering the first row and the second column. Okay, so that will be the first variable here multiplied by the second variable here, by the first variable here. Okay, that will be 1 multiplied by 2. Okay, and then the next one, okay, will be this multiplied by this. Okay, and the last one will be 1 multiplied by 3. Okay, now we are now done with the first row. Okay, we are done with the first row of the resulting matrix, because since we are multiplying by a 2 by 3 matrix by a 3 by 2 matrix, it is very, very important to know that we are going to have the result will be a 2 by 2 matrix. So with that, let's now move to the second row of the resulting matrix. Okay, now we repeat the same order. Okay, that means we are working with this and this. Okay, we're working with this and this, so that means we will have -1. Okay, -1 multiplied by 4. Okay, that means we take this and we take this, right? And then now we are now talking about +3. Okay, multiplied by 1 +2 multiplied by 2. And then we'll now look at -1, looking at the second column. Okay, now we're coming here. That'll give us -1 multiplied by 2 +3 multiplied by -1 and 2 multiplied by 3. Now having done this, we can now evaluate and say 1 times 4. Okay, that will give us 4 plus 2 plus 2, and this will give us 2 plus -2. Okay, plus 3, and this will give us -4 plus 3 plus 2 plus 4, and this will give us -2 -3 and plus 6. Okay, now we will then simplify further, and we know 4 plus 2 plus 2 give us 8. Okay, and 2 plus -2, that's 2 minus 2, that's 0, plus 3 will give us 3, and -4 plus 3 plus 4 will give us 3. 2 -2 plus -3 plus 6, that's -2 minus 3. Okay, that's -5 plus 6, that's -5 plus 6, that will give us 1. So having established this, I know it is quite very hard to take in, so we will take one more example. Let's take we will take quite a lot of examples now. So let's look at question 2. Let's say we have 1 2 and -2 4 multiplied by 1 0 and -1 3. Now this is a simple matrix multiplication. Okay, so we have a 2 by 2 matrix multiplied by a 2 by 2 matrix. Okay, so the first thing we ask ourselves is it possible? You know that the number of columns here and the number of rows here are similar. Okay, so so yes, it is possible. Okay, because they are equal, so our resulting matrix will now be this by this. Okay, so our resulting matrix will be what? A 2 by 2. Now, having understood that, now let's perform the matrix multiplication. Okay, so let's perform the matrix multiplication. So with that, we are taking the first row. Okay, we are taking the first row and we are multiplying by first row of the first matrix. Okay, multiplied by the first row, or yes, so we are saying we want to multiply the component of the first row of the first matrix by the first column of the second matrix. Okay, so we'll say 1 by 1, okay, plus 2 by minus 1. Okay, so the second, since we have taken all the components there, the second one will be to multiply the first row of the first matrix by the second column of the second matrix. Okay, because we are moving from to the first row. Okay, first row, second column. Okay, we are moving from the first row, second column. So we take the first row of A and the second column of B. Okay, so the first row of it has 1 by 0, okay, plus 2 by 3. Now the next is to take, we are now moving to the second row, first column. Right, so the second row of A and the first column of B. So we are talking about minus 2, 4 and 1 minus 1. So we have minus 2 multiplied by 1 plus 4 multiplied by minus 1. Minus 2 multiplied by 1 plus 4 multiplied by minus 1. Okay, now the last one will be considering this second row. Okay, we are now in the second row of the result. Okay, and this second column. Okay, so the second row of A multiplied by the second column of B. So we are looking at the second row of A and the second column of B. So that means we're saying minus 2 multiplied by 0 plus 4 multiplied by 3. Okay, so now we can now simplify further and say that 1 times 1, okay, plus 2 times 1 will give us 1 plus minus 2, and 1 times 0 give us 0, 2 times 6, 2 times 3 will give us 6, and 2 minus 2 minus 1, minus 2 times 1 will give us minus 2, plus 4 times minus 1 will give us minus 4, and the last one, this column, and minus 2 times 0 will give us 0, plus 4 times 3 will give us 12. So having established that, okay, we will now have it to be what? 1 plus minus 2 will give us minus 1, 0 plus 6 will give us 6, minus 2 minus 4 give us minus 6, 0 plus 12 give us 12. Now this has helped us to generate a standard on how we solve this. So let's pick one more example on 2 by 2 matrix multiplied by another 2 by 2 matrix. So 3. Now, as much as possible, we are trying to reduce the numbers, the degrees, the largeness of the numbers, okay, so that it will not be excessively large. Okay, because we don't want to have very big numbers. Okay, so with that, let's say we have 1 2 3 4 here, and we have 0 1, or let's say 3 minus 2 4 also. So, and then we want to perform the matrix operation. Now we know that this is 2 by 2 and this is also 2 by 2. Are they possible? Is the multiplication possible? Yes, it is possible. So with that, we know that the result will be 2 by 2 matrix. Okay, so let's add on for a 2 by 2 matrix. So this will be, since we know that our final result is a 2 by 2 matrix, so we have 2 rows, 2 columns. So this will be the first row. Okay, first row, first column. Okay, first row of A, first column of B. Okay, so first row of A, second column, or first column of first row of A, sorry, and first column of B. So the first row of A is that's 1, okay, multiplied by 0 plus 2 multiplied by minus 2. Okay, now we'll move on to the next, and this one shows we are still on the first row. Okay, and now we are in the second column. Okay, so we're in the first row of A, and we'll be dealing with the second column of B. So this is the first row of A, and this will be the second column of B. So that means we have 1 multiplied by 3. Okay, 1 multiplied by 3, and 2 multiplied by 4. Okay, now the next is we're dealing with, now we are entering the second row. Okay, and first column. So second row of A, okay, and first column of B. So this is the second row of A, and this is the first column of B. So in that case, we'll be taking 3 and 0, we add it to 4 and minus 2. Okay, so after that is done, we move to the last case, where we'll be dealing with the second row, okay, and second column. So in that case, we are dealing with the second row of A and also the second column of B. So having done that, we know that these are the variables, so that's 3 multiplied by 3 plus 4 multiplied by 4. Okay, so in that case, we can now solve further, and it is 1 times 0 is 0, and 2 times minus 2 is minus 4. Okay, and 1 times 3 is 3, and 4 times 2 is 8. Okay, and we move to the green color. That's 3 times 0 is 0, and 4 times minus 2 is minus 8. And so the last color, we have 3 by 3 to the 9, and 4 by 4. Okay, that's what times 4 is 16. So so now simplify further. We have it that 0 plus minus 4 will give us minus 4, 3 plus 8 will give us 11, 0 plus minus 8, okay, will give us minus 8, and 9 plus 16 will give us 25. So with this, now we have simplified the multiplication between 2 by 2 matrix. Okay, so I believe if we have any 2 by 2 matrix being multiplied by each other, we'll be able to deal with that accordingly. So now in a moment we will be, let's take another example. Now we'll be considering quite some heavy numbers. So let's look at 475, 476, or 231 being multiplied by 859. Now we can see that this is a 2 by 3 matrix. Okay, and this is a 3 by 1 matrix. The number of columns here and the number of rows, they are equal. Okay, so yes, the multiplication is possible. Okay, and the result, okay, will be what? A 2 by 1 matrix. Okay, we've dealt with all this in our previous video. Okay, so the result will be a 2 by 1 matrix. Okay, so now we can now draw something. It will have 2 rows and it will have a single column. 2 rows and a single column. Okay, now we are after a 2 by 1 matrix. Okay, so in that case we will have two simple multiplications. So the first one will be row 1, okay, like we first row, like we usually do. First row of A, okay, combined with the first column, yeah, with the first column of A. Okay, now you will notice that this of B, sorry, you notice that this B is a column matrix. Okay, so let's put that into emphasis. Now the first row of A multiplying by this. Okay, so we'll have 4 by 8 plus 7 by 5 plus 6 by 9. Okay, now the second, okay, we have two rows, and a single column. So the next one we will be considering is the second row of A against since it is a column matrix, okay, and we are still in the first column, okay, against the first column of B. Okay, so this will give us 2 times 8, okay, plus 3 times 5 plus 1 by 3, 1 by 9 rather. Okay, so with respect to that, we can now solve further and say that 4 by 8, okay, we are dealing with the blue ink now. 4 times 8 is 32, 7 times 5 is 35, 6 times 9, okay, is 54, and 2 times 8 will give us 16, 3 times 5 will give us 15, 1 times 9 will give us 9. Okay, so with that, let's go back to our black pen, and then when we simplify it further, we will have 121 multiplied by 40, and 121 and 40. So we will say that this is a 2 by 1 matrix like we have predetermined it to be. Okay, so matrix multiplication is not as complicated as people take it to be. So quickly, let's take another example. Okay, I really want us to have a in-depth knowledge of matrix multiplication, so that by the end of it all we will have extra fun on it. So we will take maybe 2 more examples, and then we'll call the video off. And let's say 4, we have 4, sorry, 2 3 5 1, okay, and we have 4 6 0 7, and we are multiplying by 3 4 2 9. Now we can see that this is a 2 by 4 matrix, okay, and this is a 4 by 1 matrix. Okay, now we can see that the number of columns here is the same as the number of rows. Okay, so yes, the matrix multiplication is possible, and our result will be what? 2 by 1 matrix. 2 by 1 matrix. Now we can see how a complex matrix as large as maybe can be reduced into the smallest bits. Okay, so now to have a 2 by 1 matrix like we did earlier, okay, so in that case, let's have our blue pen. We can even reduce the size so that we can have something tangible to work with. So our first row, okay, this will be the first row, okay, of A multiplied against the first column of B. So we have the first row of A multiplied by the, apologies for that, multiplied by the first column of B. So we have 2 multiplied by 3, okay, plus 3 multiplied by 4 plus 5 multiplied by 2 plus 1 multiplied by 9. Okay, now the next we'll consider, since we are talking about 2 by 1 matrix. Okay, so we have 2 rows, okay, and a single column. So we'll be dealing again now with the second row of A against the first column B, right? So this is the second row of A. Okay, this is the second row of A and the first column of B. Now we are talking about 4 times 3. Okay, 6 multiplied by 4 plus 6. Okay, 0 multiplied by 2. Okay, and 7 multiplied by 9. So having done that, we can now evaluate the this. Okay, so 2 by 3 is 6 and 3 by 4 is 12, 5 by 2 is 10, 1 by 9 is 9, and then we can evaluate these. Okay, so 4 by 3 is 12, 6 by 4 is 24, 0 times 2 is 0, 7 times 9 is 63. Now going back to our black ink. So okay, I think we made a mistake. This should be addition instead of multiplication. Okay, and no one is above mistake, so we have to ensure that mistakes are minimum. So we are adding, not multiplying again. Okay, so 6 plus 12 plus 10 plus 9 will give us 37. 12 plus 24 plus 0 plus 63 will give us 99. Okay, so let's take one more example. Okay, one more example. So now let's say AB. Yes. Or let's take 2 more examples. Okay, which is very, very important. Okay, so we are given matrix A to be equals to 1, 2, 3, 4, 5, 6, and we want matrix B to be equals to 7, 8, 9, and 10. Okay, 10, 11, 12. Okay, now the first thing we want to evaluate is AB, or A multiplied by B, and the second is BA. AB and BA. Now when we multiply these two, we will then look at the similarities between them. Okay, the similarities between them will help us to come up with the properties of multiplication. Okay, so let's consider the first one, AB. Now the order of A, as we can see, is 2 rows and 3 columns. Okay, yes, it's 2 rows and 3 columns. So in that case, we have it to be 2 by 3 matrix, and then we are multiplying it by, if you look at the order of B, we have 3 columns, 2, but also we have 2 rows. Okay, so that's 2 by 3 matrix. Okay, that's 2 by 3 matrix. Now we can see that the order sorry, this is 3 by 2 matrix. Is row by column. Okay, so we can see that the number of columns here is equal to the number of rows in B. So yes, okay, since they are the same, you can see that yes, the multiplication is possible. Then at the end, we will have our results to be 2 by 2 matrix. Okay, this will be the result. Okay, now if we now consider BA, okay, now we consider BA, we will see that BA is saying that the as we can see that the order of B is 3 by 2 and the order of A is 2 by 3. Of course, the number of columns in B is the same as the number of columns in A, right? So in that case, definitely our results will be what? Okay, 3 by 3 result. Now we can now realize, we can now see that AB is not equal to BA. So this means that matrix multiplication, okay, matrix multiplication, okay, is not commutative. Okay, so we will quickly solve these two examples and then we go. Okay, so because AB, let's start with A. What is A? A is 1 2 3 4 5 6 and B is 7 8 9 10 11 12. Now we know that the result is what? 2 by 2. Okay, so the result is 2 by 2 matrix. See 2, that's going to be pretty large. Okay, 2 rows, 2 columns. Okay, so without wasting much of our time, so the first one will be what? The first row, okay, and the first column. Okay, that will give us 1 times 7 plus 2 times 8 plus 3 times 9, and this, the element here, okay, we will be talking about the first row also, okay, and the second column. Okay, first row, second column. So we have 1 times 10, okay, plus 2 times 11 plus 3 times 12. Okay, and we move on again to the second row. Okay, that will be the second row of A multiplied by the first column of B. So we will have 4 times 7 plus 5 times 8 plus, okay, 6 times 9. Now having done that, we move to the last. So we'll have 4 by 6, 4 5 6 multiplied by, that's the second row, multiplied by the second column. So that will give us 4 times 10 plus 5 times 11 plus 6 times 12. Now solving for that, we have 7 plus 8, sorry, plus 16, because 8 times 2 times 8 is 16, and 3 times 9 is 27. Now we have 1 times 10, we are here now. Okay, we have 1 times 10 to be 10, 2 times 11 to be 22, 3 times 12 to be 36. Now we have 4 times 7 to be 28, 5 times 8 to be 40, 6 times 9 to be 54, and 4 times 10, okay, to be 40, and 5 times 11 to be 55, 6 times 12 to be 72. As usual, let's go back to our black ink and then this will result into 50, 68, 122, 167. So with this, we will have our results to be 2 by 2 matrix. So having done AB, now we want to evaluate BA. Now let's write down the most important thing when performing matrix multiplication is to write down your matrix. Okay, so write down your matrix in the correct order. Okay, now we are starting with B, and B is 7, 8, 9. 7, 8, 9. It's more better. Yeah, 7, 8, 9. 10, 11, 12 multiplied by 16. The body is quite tired. Multiplied by 1, 2, 3, 4, 5, 6. Now, in this case, we will now perform our matrix multiplication. Okay, now we know that the result is for here. Since we know that this is a 3 by 2 matrix and this is a 2 by 3 matrix. Now, since this is equal to this, the result, okay, will be a 3 by 3 matrix. That's quite big. Okay, that's quite big. So let's have a very big one. Okay, of 3 columns and of 3 rows. So let's begin. We'll find sheets of color later, I believe. So we'll start with the first row, of this and this second row, and the first column rather. Okay, and that will give us 7 times 1 plus 10 times 4. Okay, and then we move on again to find the first row and the second column. That will give us 7 times 2 plus 10 times 5, and we proceed on to evaluate this multiplied by this. Okay, and this will give us 7 times 3 plus 10 times 6. Okay, now moving on to the second row. Now we'll have the second row of B multiplied by the first column. That's 8 times 1 plus 11 times 4, and still on the second column you will have its second row by the second column. That's 8 times 2 plus 11 times 5, and thereafter we now have to look for shades of color. So let's pick yellow. Hopefully it's a good color. So we are still on the second row, so we have the second row by this. Okay, that will give us 8 by 3, okay, plus 11 times 6. Now we want to move on to the final colors. So let's pick a shade of this for everything, which is going to help us. So we have this multiplied by this. Okay, so in that case we'll have 9 times 1 plus 12 minus 4, and then let's move on. This nope, let's find another shade. Oh god, it is very, very important that you know colors this life. So we have this multiplied by this, so 9 times 2 plus 12 times 5, and then finally, almost done. Let's make it very thick. This, so it will be this like this. Okay, that's quite an analogy. 9 times 12, 9 times 3 rather, and we add it to 12 times 6. Okay, so having done that, let's stick to our single color for our analysis. Okay, instead of looking for color letter scatter. So we have 7 plus 40, right? And here we'll have 14 plus 50. We have 21 plus 60. Okay, 8 plus 44. 16 plus 55. 24 plus 66. 9 plus 48. And 18 plus 60. 27 plus 72. Now at the end, we will see that 47, 64, 81, 52, 71, 90, 57, 78, 99. Oof. Now, since we have seen that an important characteristics of multiplication is that multiplication is not commutative, because a b is not equal to ba. And finally, okay, as we wrap up, that multiplication of matrices is defined, okay, is defined only when the number of columns in the first matrix, okay, is equal, okay, to the number of rows in the second matrix, okay. So, and we perform quite a lot of examples, okay, quite a lot. I know the first one was quite messy, but after watching this and you feel you have to go over this video again, you can just start right from there. And then I believe God that as we watch, you will have good and established understandings on this. So we just take the rows multiplied by the columns, okay. So this will bring us to the end of this video. We did about we did 2 by 2 matrix multiplied by 2 by 2 matrix. We did 2 by 3 multiplied by 3 by 1. We did 2 by 4 multiplied by 4 by 1. We did 2 by 3 multiplied by 3 by 2, and the like. So we did about 7 examples, okay, and we arrived, we applied all what we've been doing so far. So in our next video, we'll be talking about determinants of matrix, and also transpose of matrix. So with this, we have come. Please, I pray that understanding is established in the mighty name of Jesus.